Hello everyone, this is Mr. Appel, and today I'm going to show you how to solve a special kind of unique case of an equation, an exponential equation. So looking at this equation, you can see that it looks a little funky. You've got an e to the 2x and an e to the x. Sorry, my wife is printing something at the moment. Hopefully that noise will go away momentarily. Wow, that's loud. So what we're going to do here, sorry about that, what we're going to do here is a little trick, which is I'm going to set y equal to e to the x power. And that's going to look a little weird, but just roll with it here. So I'm going to set y equal to e to the x power. So this equation then is really, another way to write it is e to the x squared minus 3 e to the x plus 2 equals 0. And so I probably should have shown you that first. So if you see that you can write it like this, and again, not obvious, but this is kind of a unique situation, but it's something that happens enough in pre-calc and again in calculus that it's a pretty cool technique that you can solve certain equations with. Okay, so we're going to set y equal to e to the x, and now I'm going to take that and substitute y in for e to the x, and watch what happens when I do that. So I get y squared minus 3y plus 2 equals 0. And now we have a pretty simple equation to solve, actually. We can just factor that. We get y minus 2, y minus 1. So y is equal to 2, or y is equal to 1. So pretty simple to solve. And now if we go back to, remembering we're really trying to solve for x, if we go back to this, y equals e to the x power. So y is e to the x, so e to the x has to be 2, or e to the x has to be 1. And so now we just solve each of those equations. Well, this one over here is really easy, because what to the e to the what would give me 1? Well, that's just 0, because anything to the 0 power would be 1, so x has to be 0 for that one. And over here, just like we did earlier, we're just going to use, we're going to rewrite it as a log, so that's going to be the natural log of 2 is x. And so the x in this case is natural log of 2, or if I wanted an approximation, it's about 0.693 if I'm approximating it to the nearest thousandth. And those would be your two solutions to this equation. So you can actually solve an equation like that algebraically, even though it's kind of funky looking. If you wanted to take a look at what this looks like graphically, what happens is it does some really kind of strange stuff. You see it it's sort of trailing off there, and as it approaches, it actually crosses right at the origin, dips down below, and then crosses again. But you see, it's a little hard to see on this graph. You might want to graph it yourself. It does, in fact, cross the x-axis in those two locations that we found algebraically. So kind of a cool technique. Again, it's going to have some later applications in calculus, but this is kind of an introduction to a creative kind of substitution. So hope that was helpful. That's all for now. Thanks.